integration for better productivity within CAESAR II and CADWorx planned professional software. How we can do, what are the things we can do it with it. We'll have a look on it. The first and foremost thing for a CAD engineer would be onto the specification editor, wherein the base of any CAD model. So for CADWorx is the specification editor, where what are the pipe diameter, pipe thickness, pipe schedule, pipe material, everything is being described in the specification editor, and that is what is going to be carried forward for our isometrics or the PCFs. Everything would be interlinked with that spec editor. So what is that in the spec editor? We'll be looking it in. What are the details we can do it in our spec editor? We'll have just a look. Okay, so here we have the details. Sorry, it's not the video. Video got skipped out. Okay, this is the spec editor. So here, first, the most of these components, this is the integration project file, which has specifically created for our integration purpose, for the demo purpose. So here I have the pipe. Now, the most important thing for any pipe is just schedule. So by default, in most of the default specs, whichever are available, it will be given as specification schedule. The specification schedule can take it as XS or double XS or anything as per the requirements or standard. And second most important thing is the description. So description, when we collect the details of the description from the catalog and everything, then this the schedule thickness, pipe diameter, everything will be read as per the catalog which you are defined. It's not just for your pipes, it's for the entire components and everything. So when I give the schedule thickness as standard, already in the catalog I defined it for the standard. So those whatever the thickness has been defined in the catalog, it will be taken care here in the model for all the components. So it's always advised that instead of giving it as a specification schedule, it's advised to give the actual schedule which is to be utilized for the particular component, and also the description, long descriptions, everything to be read along with your catalog data. Instead of giving it as manually, we can read it along with your catalog data. So that reduces me the time, it saves me lots of time, and it takes the actual catalog data with the actual value which we are giving it out. So that helps me in all the process in data transfer, everything without any losses, because there are few cases where we might get some huge data coming into our model. So that this work on the spec editor will help me in doing that details before going into the other options. So that's the first step which we need to do it in our specification editor. So once the specification editor details are done, the next step is our CAD model, which any CAD engineer can do it with the always correct spec details is done. Then the CAD model will be 100% done. Now, once the CAD model is ready, the next step is to transfer this CAD model, that is especially the pipe routing, which needs to be analyzed to the stress engineer. So that's what we'll see it in our next video. So which is having the PCF file generation. So as such in CADWorx, prior to 2018 everything, there was an option called .c2 file, but there was some data losses such a way that the supports were not transferred properly. Those things were happening. So to overcome those details, in latest we have something called C2 PCF, which along with your pipe support data, pipe model data and everything, you can even transfer your process data also along with your details, like your temperature, pressure, design pressure, operating pressure, or any other temperature pressures which you want to take along with your details. That can also be transferred into your along with your PCF file. Here we'll look into it details. I'm sorry for this audio. Okay, so I'll just give you an explanation here. So this is my simple pipe taken from a vertical vessel to a pump, and for I have to make the video clear, I have hidden other components of the model. So the vessels and everything, I have hidden it. So this pipe traveling over the rack, and here I have the details. So here I can do this C2 PCF is the command which I can go for the generation of your CAESAR II file, PCF file. So you can use your C2 PCF, or else you can use your system out command. Both are same, which gives you the details to your model. So once that is done, you can select your pipe material. Schedule is standard. Standard schedule for a 12-inch pipe is close to around 9.5 mm. So the same thickness will be coming. Either you can use your system out, or you can just command call C2 PCF, which takes you the model to your C2 PCF file to your output window. So you can give your name of your pipe. So here I'm just giving the stress PC pipe stress, and I'm saving it. That is the PCF file. And the most important thing is your icon figure, using the style which you want to use. Now, when I speak about style, by default, the isometric style from the CAD engineers, whichever you are setting, the same style you can use it, or else here the current setting which I used is my Caesar to isometric style. So I can use that style also. Then the project setup. In your isogen project setup consists of all your other parameters which you want to use it. So if you want to use your design pressure, select that box and give your value with your units, corresponding units, and your design temperature similarly, and the other parameters what you require to be transferred to your model, like your operating pressure and operating temperature, or you want to transfer some other fluid weight or fluid density or anything which you want to give it along with your model. You can say give those details in your input screen, and you can send it across to that. Okay, you can give it to your input screen. I'm sorry for the video discussion, and you can send it across to your PCF file. So once these details are done, you can click on the other details and say okay. So there are 4 data to be transferred to my model to along with my PCF file. I'm just saying it as okay. And once the isometric style, just say okay. Then the regular process. Select the line numbers which you want to transfer to your PCF file. Currently, I have just made it as with your one line only. Other lines I have made it as an extra, so it's not displayed here. So the line number has been transferred. When I go into my system folder and the location where the file is been located, I'll be having these details of the file, which is this is a pipe stress PCF file. When I open it, I have the entire data of the pipe along with your design pressure, pipeline reference, design temperature, operating temperature, along with the pipe components, weight, material. Every data is loaded straight away. So this data is what we need to map in your CAESAR to take it further. So these are the 2 steps which a CAD engineer will be doing it, and whatever the data will be what the CAD engineer sends, that will be stored in the PCF file. Then it's the responsibility of stress engineer to map this in the CAESAR window, so that all the data which has been transferred by the CAD engineer is been taken over in CAESAR straight away. So let's move further. So what are the options we have in CAESAR? So by default in CAESAR we have 2 options of importing the PCF file. One, in the home screen of your CAESAR window, where you have under the importing CAD import files, where you can import your PCF files. This is available under your integration option in the first window of your CAESAR itself, where you can import PCF file, and this is your basic PCF import. What are the things? All mapping, everything can be done in this basic PCF import, but one thing, for each PCF file, you'll be having each CAESAR file created. You can go for multiple PCF file importing, but for each PCF file which you do, you will be getting one individual CAESAR file also created. Also, you don't have the option of controlling your node number sequences, all those stuff. Everything will be automatically selected by the software, and accordingly it will be going on with this in your basic PCF file. So there's one more PCF file called as advanced PCF file, which is located inside the CAESAR window in the main modeling window of CAESAR under the environment ribbon. With this advanced PCF file import, along with the options which are available under PCF import, we have the additional options like create a new model or add elements to an existing model. These stuffs we can do it. or control element sequencing. So if you want to have any block sequencings to be created, we can control it over here. Or you can even define and control node numbering systems. You can very much do that. You can even increment your build and verify the model, creating as many PCF files as needed. Suppose say for a single CAESAR to file, single line number, you have got some 4 PCF files created, and you using advanced PCF file, you can merge these 4 PCF files with the node sequentials and create it as a single CAESAR to file. Whereas in basic PCF file, for basic import format, for all the 4 PCF files, you'll be getting 4 CAESAR to files. That's a major difference here. Then in the advanced PCF files, the basic options in the main window is your condense options. Now condense option has 3 things: condense rigids, condense tees, and condense elbows. Now condense rigids are nothing but, say, the most common rigid assembly will be your valve assembly, which contains your valve, flange, gasket, valve, gasket, and your flange. Now when you are converting this to CAESAR, when you are converting this model, I might require to have it as flange, valve, flange, or I might have it as a single element. So if I make it as true, the entire assembly will be a single rigid element in my CAESAR to window with the combined weight given into that single element. No, I don't want to have it as a single element. I want to have it as flange, valve, flange, so that I can even perform a flange evaluation checks and other stuffs in CAESAR. Then I can make the condense rigid as false. Then when converting, CAESAR 2 will create a flange element, valve element, and a flange element. So that's how CAESAR 2 will be creating it in under condense rigids. Similarly for T's, if you make it as T, condense T as true, then for your T, there will be only single node created at the node intersection point with the major pipe, the T components condensed with your main pipe, and the SIF at that node number would be created. If I make it as false, then the actual T length element for your branch and the header sections from the central, say, intersecting node number would be created, and the T element will be created, and the T property at that intermediate node, the junction node, would be given, the SIFs. And finally the elbows, condense elbows. Similar to T, if you want to condense your elbows, if you make it as false, then the elbow will be created as an individual element. But if you make it as true, the elbow will be condensed and clubbed with your pipe, and the output would be condensed in form. So the default settings for your condense options would be always true in CAESAR. So it's up to the user to decide whether he wants to have it as false or true. It's up to the user to decide it. Next, use pipe materials. So default option will always be true for this. So pipe material is nothing but, so for component attribute 3, according to the PCF file generator for either your smart plant from smart plant 3D or from your CADWorx, you have the material for material identification is component attribute 3. So by default, whatever is the material property given, that would be read. If I make it as true, whether the elbow material or a flange, everything would be condensed and single pipe material will be used throughout your model. If I make it as false, then for elbow, the elbow corresponding material, if it is mapped with my CAESAR to materials mapping, that will be selected. And similarly for your flanges, if it is mapped with my flange materials, that material will be selected. Similarly for your T's and everything. So that is your condensed materials. Then diameter limits. So north direction as usual, plus x minus x or plus z minus z, which direction you want to have your north to be established, you can select it according to your requirements, either here, or you can select it once the model is ready, you can select it inside internally also. Then you have diameter limit. So now when these diameter limits will be helpful. Now I have a model which has lots of tapping. Say I have a line of 14-inch long line containing lots of tapping connections for like pressure gauges, temperature gauges, or some other utility lines, small utility lines of half a meter or close to around 1 meter length. These tappings, the diameter is less than 2 inch or less than 1 inch. the maximum largest diameter of these tapping connections are around say 2 inch. And during the conversion, I don't want to utilize them in my scissor to model if I have a flexibility of it. After importing, I don't want to delete it. But when the PCF file is getting converted itself, that time itself, these tappings, everything has to be eliminated. Then I can give the values by specifying the DN limit. That is the nominal diameter I need to specify in inches. That is 2 inches if I am using it in English units, or the corresponding unit I can specify it here. Preferably will be always in English units. So once I specify it as 2 inches, then any pipe sizes less than and equals to 2 inches under the tapping connections will not be converted to your from the PCF file to your scissor to file. But if you want to include all your tapping connections, then instead of 2 inches, we need to put a value as -1, which makes all the pipes will be included in the pipe conversion process from PCF to scissor to file. Sorry. Then we have something called elemental properties like length of node increments. Standard increment which we maintain is 10, but I don't want to maintain the standard increment, but I want to maintain an increment in accordance with the pipe length or something like that. Then I'll just give the nodal increment multiplication factor as say 10 times the actual pipe length. So suppose say the pipe length is 5 meter. So it will be broken into, it will be created as a node element. The broken into 10 times of the nearest value will be multiplied and the node increment will be created. That's how the material nodal increment would be given. And material number, default material number, I can keep it as low carbon or A106 grade B or whatever it is. Now why this is required? There are few cases where the materials may not be linked, like your gasket materials, bolt materials, or your flange valve materials. These are not available in our Caesar 2 window. Those materials, those elements which does not, for which the material mapping is not happening because of unavailability of the material, what material it has to apply. That is what the material number will be selected here. And similarly, for those elements where the pipe schedule is not selected or not given, what should be the schedule number taken? So that is what will be given in our pipe material number and pipe schedule. This will be the first option in our conversion option. The second will be your mapping, PCF mapping. So here it gives you the dialog box where the definition of your PCF mapping for the software is done. So what is that we'll be doing it here? We'll be using the changing the mapping of PCF keywords to the Caesar 2 attributes. So Caesar 2 has some predefined attributes. To that attributes, what should be the against that, what should be the PCF attributes to be utilized? Say for example, design temperature. If in case the Caesar 2 PCF attribute is having component attribute as 10, then I'll map this. So component attribute 10, whatever is the value against it, that should be coming under T1. Or component attribute 12, which is corresponding to design pressure, say for that should come under P1. So this is what I'll be categorizing it in my first mapping steps. So the most thing is keywords and the attributes. So we can even customize our attributes for your cladding thickness, cladding density. If in case you want to, those details also needs to be transferred, then that also can be done under this mapping. So when I go for PCF mapping, in whether I go for my basic PCF import or the advanced PCF import, I have two types of PCF mappings. One is called as stress ISO PCF mapping. The other one is called as super ISO PCF mapping. Now, since CADWorx, Caesar 2, everything was coming from under single family from COED till now to Hexagon, the super PCF will hold good for CADWorx to Caesar 2. So whenever I'm having a CADWorx PCF exported from CADWorx, then the mapping I can use it as super PCF. Other than CADWorx, any other softwares, including Smart 3D or say PDMS or say other CAD modeling softwares, you can use your stress ISO mapping PCFs. So according to that, what is that keywords you can enter? I given just a brief keywords in the display screen, but once we go into our software, we can see the other details also. Where pressure, temperature, what is the attribute you have in your basic PCF. So that details we can provide it over here. And this is for your stress ISO mapping PCF, and this is for your super PCF mapping. So which holds good for our CADWorx to CAESAR II integration. So this super PCF mapping is what we'll be seeing it today. With pressure 1, pressure 2, pressure 3, everything we'll be seeing it today. Now we have done basic mapping of your PCF, that is for your process data and other data. Apart from that, units needs to be mapped. Suppose say the CAD engineer is using metric units, but the stress engineers are using English units. Then whatever is the mapping been done, that has to be converted to the corresponding CAESAR II unit value. Then only the values will be loaded properly. Suppose say I'm using there as 200 degrees centigrade in CAD engineer, and the stress engineer is not using to have this degree centigrade. He might be using degree Fahrenheit. Then the corresponding values should be converted. 200 degrees centigrade equivalent Fahrenheit value has to be provided over here. So that details will be taken care in the units mapping. So which contains, first is your CAESAR II unit, then your PCF unit, then the conversion factors. So if your CAESAR II unit and the PCF unit is PSI, then the conversion factor will be 1. Suppose the CAESAR II unit is PSI and your PCF unit is KPA or bar, then the corresponding conversion factor has to be provided in the unit file. And this mapping of unit file is an one-time work if within an organization or for a project. But if the projects are changing and the unit files are also changing for the projects, then accordingly the mapping has to be done for each and every projects. Because these are everything located in your system folders of CAESAR II. Once the mapping is done, then the next is your material mapping. So PCF mapping, material mapping takes care for your material. So in CAESAR, we have everything restricted to your code. 101, 102, 103. These are our material shortcut codes in CAESAR II. Against each, we have a material classification A106, grade B, grade A, grade C. Lots of classifications or everything is done. So what should be my model? What should be the model and everything? Materials mapping, what kind of material, and what should be the CAESAR II node number against which I created those models. Suppose say I have some user defined materials used in my CAD interface. Same thing I have created in my CAESAR II with a particular material number. So that number against that material number, I'll be mapping it. Material code which I'm used in my CAD, I'll map it so that once the PCF mapping is done, this material mapping will also be taken over automatically. Next most important thing in our mapping would be a restraint mapping. Now why it is? So restraints, we have U-bolts, we have clamps, we have hangers, we have constant hangers, variable spring hangers, we have pipe stanchions or your pipe structure supports or your elbow stanchions, different types of supports as a CAD engineer, for a CAD engineers. But the application of those supports will be the primary thing for a stress engineer. I don't bother about what kind of, what categories or what, how heavy is the support or what shape is the support. What is that going to provide me in CAESAR? What does this support does to my pipe at that node number? That is what a stress engineer is concerned with. So based on the support which this CAD engineer provides me, I will provide a support restraint mapping, and this restraint mapping is a one-time work because within an organization, the code for the restraints would be constant. Only thing would be changing is the tag numbers might be changing based on project to project, but the major concept would be the name of that support would be remaining constant. So this would be a one-time work for a project, or I can say even for an organization if in case. So CAESAR II can read within this support name in your PCF. So support name is the primary thing, and for PCF support name would be my name in my PCF file. Or there are chances that support tag. So again, in the PCF, if I have the tag for that particular support, I can use that, or I can use some item codes or a key. So different kind of support details I can provide it in within my CAESAR for my mapping. So more detail I am explaining it in the next. So PCF keywords. So keyword mapping in PCF: support name, support tag, support guide, different guides. Support guide is nothing but the numerical binary code numbers which is available in the latest CAD editions, CADWorx windows. So those details I can give it. So what Caesar to keywords you want to locate, that should be provided within that square brackets, within that brackets. Then say for example, if you are using your support tag as VG100 as the name which was specified in the previous window. Now what does VG100 does for a stress engineer at that time? So if it is a, say if it is a U-bolt type support. So by default, whenever I have a U-bolt, I'll be having a resting plate. Over that the bolt is going to be provided with some gap or clearance. So if suppose it's a resting plate, then by default I have one thing is your plus Y support with the corresponding mu value if required, if provided. Second will be your guide with your corresponding friction coefficients as along with your gaps if provided, if needed. So that details is what I'll be providing it here in this format. I hope you can see it over here. So VG100 will be the tag name or the name of the support. Under that support, for that node number, how many supports I need, how many restraints. So in Caesar, I have 6 types of restraints can be provided at a single node number. So how many restraints I want to use? 2 number of restraints. One restraint will be my plus Y with a mu of 0.3. The second restraint will be with guide with a mu of 0.3. So this is what I'm specifying it. So Caesar will take over VG100 only will be converted. If say in your PCF you have VG1, it will not read. It will read only VG100. For VG100, this will be applied. So this is the syntax: support name, space, number of supports at that location. Next line comes the restraint function, space, mu value, space, gap value in the corresponding units. Suppose say 2 mm gap, says 2 with your unit file, followed by the unit file. So this would be the restraint mapping for each and every support. This syntax follows. So support name, I cannot use their tab. It should be space bar, single space bar or multiple space bars, not an issue, but it should be space. So same thing. Suppose say specifies restraint function. So like anchor ANC for your anchor, GUI for your guide, limits, vertical hanger, or your constant spring hanger. So what is the support? These are your functions. Now vertical plus V plus Y will be your vertical. If my Caesar to axis is Y axis is vertical, then plus Y and minus Y will be for corresponding to your vertical. Eastward, north south, east west, north south. So for your X and Y. So accordingly, I'll be giving the other details for my requirements. If say I don't want to provide a gap, but I want to provide an horizontal support along the east west axis alone. So that way I can provide those supports also. And some cases I'll be required to provide my local axes also. Then the local axes would be under the name of A, B, C. A corresponds to the center line of your pipe, B corresponds to the direction attributed to the support, and C corresponds to the cross product of A and C, A and B. So these details also I can provide it when my global axis will be always vertical, north, south, or east, west. But I have the details in my local axis as ABC, then I can use my ABC axis also in my restraint function functioning details. So this is my restraint mapping. So we have seen there are total 4 types. First mapping is your material mapping, then your unit mapping, then your restraint mapping, and finally is your SAF factor mapping. So these are the 4 mapping texts, and among them, the restraint mapping is the most important thing. The unit mapping, your material mapping, as well as the SAF mapping will be a one-time work for most of the projects. But the restraint mapping might be changing from project to project. So when you are specifying your PCF component against the PCF component for any of your SAF factors to be entered, it could be for your T's, it could be for your bends or anywhere. S keys will be playing a major role here, followed by CAESAR II SAF type against that S key, followed by whether, if suppose say if it is for a T components, what should be the pad units, pad thickness or pad thickness units. Then the in-plane and out-plane SAF values can be provided, and you can work on the details straight away. So as such here, so here I have this. These are the various types of reinforcement factors. So here in CAESAR output, I find the PCF file as CRSO. That was the details provided for me in my PCF file. So against that PCF file, I want to have whenever CRSO component comes, say it's a T or tapping connection, then by default in CAESAR, there should be a pad of thickness 10 mm with your in-plane and out-plane SAF as 1.23 and 2.34. This I can provide it if I know it. If not, after coming into CAESAR, I can change it anyway. So before coming and as a standard values, if you have for your particular tapping connections, everything, then I can provide that standard SAF values as a mapping. And whenever I do this PCF mapping, these details will be taken care automatically. Okay, so let me take you to the live session now. So this was the model. So C2, which we were working. So just I'll show you the other PCF options or the other component attribute options which you can select over here under the project data. So these are the various. So currently have been using these 4 project data. So I'm just getting it over here. So you have the other project data for your alternate design temperature, design pressure, then your cleaning requirement, construction type, your date and time, design code, engineering work package, fluid code, fluid phase, form and handover stations. Lots of other details are available. Whichever is required to be transferred to the stress engineer, those data only you can utilize it, because the other data are nothing but for your inbuilt isogen for a CAD engineer who wants to generate the isometrics within this CAD interface. For that, this will be these are the other attributes which you can use, and there are lots of other attributes which you can link with different components and everything. So I'm just using these 4 details and say okay. Line number, list, this is the only line number, say okay. So the line number with the components has been created in my model. So I'm just going for those details. Okay, so we were speaking about this PCF file where these were the properties which has been coming out from my CAD engineer. So whatever the data the CAD engineer wants to get it transferred to the stress engineer, he can load it over here, that weight, component attributes. So weight, will never take this weight because this might be getting clashed with our other components. The most common, better for weight, for component weight would be your component attribute 8, which will give you the weight of the component straight away in the corresponding units. That's the most important thing which we require. Similarly, your material and all these details will be loaded in your PCF file. This is for your components. And similarly, if you go with your supports, you have various details and everything. So which we'll see it in other details in our CAESAR 2. So now let me open my CAESAR 2 file. So I'm just opening a new file. I'll say run 1. And it will give me the default unit file which I set in my CAESAR 2 window. So whatever is your default unit setting in your window, that will be your default units. You can as well as customize the unit file as per your requirements. So whenever want to the basic PCF files in the interface, this is the basic import PCF file. The best option to utilize in here will be your advanced PCF files under the environment. Here you have this advanced PCF file. Just click on this advanced PCF file. So here you will be having the options for creating various things. So if I add multiple CAESAR to files, suppose I'm just going for choose files, and I have these 2 PCF files. I'm just opening it. If you see, it will create your increment as a start node, end node increments. But if you want to club this, you can change your nodal increments as start node accordingly, and the continuity will be taken care as per the software itself straight away. So I'm just removing both. Okay. So here we were speaking about the condense options. So here condense rigid, so I change it to false. Condense tees, I change it to false. Everything. So let me make it as true, and also one first import cycle to see how my model is going to come. Okay. So this also I'll make it as false, or also make it as false. And let me choose a file. This was the recent file which I generated. Just open it. So now you need to do this PCF mapping. So PCF mapping, since this PCF file which I opened is from my CAD, I can just go and click on this stress ISO. If I'm using, if I get from the PCF files from other softwares other than CADWorx and everything, I can use my stress ISO PCF files. If I'm getting the PCF files generated from my CADWorx model, then I'll go with super PCF. So this is the details which I have under my super PCF. These are the various attributes. Again, is that each and every attributes I need to give it over here. So as far as that, my PCF files, these are my PCF files which I am having it. So in my PCF file, what are the attributes I have? The most common attributes: pipeline reference. I need to match it. So pipeline reference, that is line number, I want to have it as pipeline reference. Then I want to have my design pressure, again against pressure 1. Against pressure 1, I want to have design pressure, it's good. Design temperature, again design temperature, okay. Operating pressure, I want to have it against design against P2. So I'll just put it over here, and this I'll delete it. P3 I'll delete it here. Similarly, I'll put it over here. And what are the other details you want? I want to have my material. So component attribute 3 is for my material of my system. So here under material, I'll put it as component attribute 3. Next, I want to have it is my thickness. That is my wall thickness. So component attribute 4, where is my thickness? Here I have this wall thickness. So I just put it as wall thickness. And weight, component attribute 8. So for each and every component, what are the attributes you are using? Just put those details here straight away to read them individually. So once this is done, just click on save and close this window. So that completes the PCF mapping for all. This is a single time work. Single time work in the sense, for first PCF when you're importing, if these all the mappings are done, then it's a single time work. You can keep on generating your PCF files without disturbing the PCF mapping. I already choose my file. I'll just click on begin processing. It's not set. Okay. So I'll make this pipe material as true. Then I'll say begin process. So it has been condensed, and it will say what are the things the support U-bolt did not match any mapped support type. So by default, it will take only vertical support. That's what it has been given. And what are the other details you have? No piping spec specified. The default materials taken for these elements. Wherever some materials are not found, there the default material has been taken. These are the warnings. So you can save these warnings as an future reference. And this is the model. So by default, you can see all the supports have been taken as only your resting supports, and material is been taken. Now you are, because there is a support. Now you can see the condensed material. The elbow has been condensed. Similarly, the elbow there's a support, so this has been coming over like this question. Okay, so this is my model which has been created where I used the condense options. I'll not go more about this because the other details I will see stage wise. So I'll just say this run one has been done. I'll create a new file, run 2. Now in this, I'll again go for advanced PCF, but here I'll say condensed edges false, rigids as false, everything as false, and even this one also I can make it as false. Now if you remember, already we have done this PCF mapping, so I need not do this PCF mapping once again because the same thing is going to happen for any number of components I've used. So I'm not going to for any PCF mapping. I'm just choosing this file. So this is my file. So open it and click on begin processing. Now still the pipe supports are not matched. So that's the error. Few materials are not, that is your ASTM 234 WPB. These materials are not found. So that is being given over here. But the most important thing which you can see is here. Now the elbow is not condensed. Elbow is a separate element now, individual element. Previously the elbow was condensed. Now the elbow is an individual element. Now the elbow material could not be found. So it is taken as low carbon. Pipe material can be found. So it has taken your material as this one. So now let's go for our first option as mapping. Because wherever this mapping is not done properly, let's map them first. So where do I go for my mapping? So by default, the mapping would be located in my, all my mapping files would be located in my system folder. So I'm just going for my C drive, program data, intergraph CAS, CAESAR II, V12, system, and here I have the mapping file. Piping units map. So these are the units mapping. So you can create your unit mapping as per the requirements which you want. So PCF unit, CAESAR II unit. So you can map that details. SAF, you can map your SAFs as per your requirements. Then your material mapping is the one which we are looking out for. So here we have different materials which you want to create. You can create the mapping according to your requirements. Now we found the elbow material was not mapping. So let's see what was the elbow material been selected. Gasket elbow. So elbow material is A234-WPB. So let's see A234-WPB is available in this material or not. So you can search it out. So 234. So this is one next. So here you have 234. Now if you see, it is CAESAR, there is a material called A234 grade WPB. But in CAD PCF file, this is the A234 WPB. This is a major difference. So whatever is there in the PCF file, if you don't have the same mapping done in your mapping file, then the particular material will not be read. So now I need to first map that. So I'm just using 321 and this will be my mapping file. And I'll save this file. And this mapping file is a single time work. So for all the standard materials which you are going to utilize in your model, you can just keep on giving these mappings straight away. Okay. Similarly, if you want to utilize any other details, you can give those details also. So A193. So just I want to utilize, I'm just giving it as 103 just for our reference only. Okay. Save this. Now I'm closing this. Now let's do the mapping once again. Now we have mapped the materials. Let's rerun the file with the new material mappings. I'm just using the APCF because that has few features which we can very much use it, especially this kind of mappings and everything. So here you can go for this mapping. Same thing, you can open that mapping folders here also. So both are same thing. Choose files. So plant PCF. Begin process. Why not found? Okay. I got the mistake. There was a mistake which was done by me unknowingly. I'll just show you that mistake. While explaining, I just went for an unknown mistake. That is, the material mapping was not done properly. I just gave A234 W-WPB, but actual thing is ASTM A234 WPB. Then the details will be taken care properly. Now save this, close. Coming back to CAESAR. APCF, choose files, begin process. Now, you see material warnings. Only one, no material specified for valve line 234. So the default material has been selected. Other warnings are available only for your support and restraint warnings. Now the entire material warnings has gone. Now if you see each and everywhere, wherever previously elbow was second, now you get the material. Because the default CAESAR 2 material, I just gave the number as 231, 321. But in CAESAR, there is no material grade ASTM A234-WPB created. So it's taking the WPC, which is available in my CAESAR 2 material database. I just created those material in my mapping only, but this material is not linked with my material database of CAESAR. So for that, first the material user material customized database has to be created first. So that's the other end of my CAESAR window. So now this is my material mapping has been done. Now the most important thing, next step for me is to do my restraint mapping. So how do I do my, what are the various types of restraints I'm having in my model? Let's see that. So these are my supports. So here I have U-bolt tag. Then there are majorly U-bolt, and one new support used is your support stanchion, elbow support pipe stanchion. So this is in support. Now I need to map this for my CAESAR 2 window to work out. So here I have this restraint mapping. Open this text file. So here you have some predefined, already created some restraint mappings are already there. So first I want to use with my name and tag. So what is that? Both for tag and name, everything should be the name. So what is the advantage of this? If suppose a tag is also given as name, so whatever is in your PCF file again as the name, so that will be going and sitting in your tag in your restraint also. So that's the advantage. So let's do this support mapping first. So first, what is that I want to utilize? I want to go for U-bolt. So I'll just copy this. So the space bar, spellings, everything should be very carefully given. So I want to use two supports at that location, plus vertical mu equals 0.3. Again, I want to use guide mu equals 0.3, and I want to use a gap equals 1 mm. Sorry, space mm. So that's what is given, space unit, or 1.00 you can use it. So this is one support for U-bolt. So wherever U-bolts are there, this support will be provided. Now, wherever pipe stanchions are there, so the name should be perfect. Elbow support pipe stanchion. So entire name has to be copied. Plus vertical mu equals 0.3. Then I want to have east west mu equals 0.3 with gap equals 2.00 mm. North south mu equals 0.3, gap equals 2.00 mm. So this is the restraint mapping I have done for the same model. I'll save this. So since I saved it in the same location, the existing mapping file would be replaced with the new thing. What are the updated things? So no need of deleting the previous mapping done, because this might come in your future projects also. So no need of deleting the existing mappings done. Just keep on amending the new support restraints which you come for your new projects. So that's the best advantage of using the same mapping files. Now let me create a new file, run 4. So for each run, I had created a different CAESAR II files only. So advanced PCF files, no mappings, everything is already done. Just choose the file. So this is the PCF file. So no other data to be selected or anything. Everything is remains the same thing. Just click on begin process. Okay. The elbow support did not match. I guess somewhere I did done some mistake there. Let me check what was the mistake I done in the mapping. Okay. The elbow support, I just gave the name, but how many supports to be selected in that location, I did not give it. So that's what it did not read. So I'll give it as 3. Save this. I'll re-import it once again. So at each and every support type, how many restraint R1, R2, R3, R4, R5, R6, how many restraints you want to select. So that is the number which you have to give, which I forgot to give in the previous run. So that's what has been done now. Now I'll click on begin process. Now only the material warning is there. That's that too only for your valves. Now if you see, you can see the support. Plus Y, X, Z. So okay, the units has been read as inches there. So that was the mistake. So it has taken as 50 mm as the gap here. And here it has taken as 24.4 mm as the gap. So the unit has to be matched properly. So I did not match the unit files. If you remember, I did not create any unit file mapping. So that's the difference here which has come over here. So the tag has been selected because support tag I given it as name. So whatever again is the name, whatever is the tag, that has been taken under the tag here. So if in case if you are given some tag, then that would also be taken care over here in the model details. Okay. So the advantage of this, the tag, everything can be printed in your isometrics. So verification of isometrics, cross verification with different departments, everything would be easy for you in your future details and everything.